Hi there, my name is Thales, and this is Scientists in Action.
Hello, my name is Lucas, and in this video you will learn about the most famous theory about the origin of the universe.
Are you ready? Then run the vignette. We are aware of our emergence from 10 to the minus 43 seconds from the beginning to be exact. This era was known as the Age of Planck. At that time, all matter and energy in the universe was condensed in a small space 100 billions of times smaller than an atomic nucleus. All the matter that makes up all the hundreds of billions of the galaxies was condensed in this unimaginably small space, and none of the fundamental laws worked. At about 10 to the minus 36 seconds, we entered a new era, the era of grand unification. The temperature of the universe at this stage was 10 to the 34th Celsius, where we expected the universe to be a very bright little ball that would blind anyone that tried to see its magnitude. But in fact, the compacted matter was so compact that light could not pass through. The universe was dark and gloomy. On this energy scale, three of the four fundamental forces had the same intensity: the electromagnetic force, the weak nuclear force, and the strong nuclear force. You might be wondering why the universe has so much matter in such a little space and it still hasn't turned into a black hole. Part of this is probably due to the inflation process. In about 10 to the minus 32 seconds, the universe expanded by about 100 trillions of times. So maybe the matter didn't have enough time to compact itself into a black hole. From then on, the universe was expanding and cooling itself. At this temperature, we were already able to apply the fundamental laws of modern quantum physics. Protons and neutrons are the particles that form the atomic structures and are formed by quarks. Even more fundamental particles that constitute the protons and neutrons that are expressed by gluons, fundamental particles that carry the strong force. After 10 to the minus 12 seconds, the universe was made of these particles, starting the age of quarks and gluons. Then the age of hadrons, where the universe was already 10 light years long. The expansion of the universe has certainly exceeded the speed of light. After 10 seconds from the beginning, all matter in the universe was composed of radiation. About 3 to 20 minutes after the emergence, we had the formation of the first nuclear and the beginning of the first gravitational imbalance, where before the matter was distributed homogeneously, now no longer, creating the galaxies and planets we know. About 50,000 years after the beginning, the expansion of the universe begins to slow down, and only after 380,000 years it cools down enough for the formation of atoms. Almost 100% of the matter was made of hydrogen, with a small portion composed of a mixture of deuterium, helium, and lithium. After so much time and so much expansion, the universe finally cools down enough for the first rays of light to pass through. The first stars would be composed primarily of hydrogen and helium, and emitted much of their luminosity in the ultraviolet range. Due to their large mass and composition of elements, first-generation stars would have a relatively short life, with ages determined by the amount of mass of the stars. Then came the second generation, composed mostly of hydrogen, but some were formed with heavier elements that were formed by the old generation stars, such as oxygen, carbon, iron, and others. And a fun fact is that our sun probably comes from a second generation. After the emergence of the heaviest elements and new nuclear fusions of the stars, which ended up exploding and releasing these elements which agglutinate with particles, the planets appeared. About 3.8 billion years ago, on a planet called Earth, certain molecules combined to form structures that were initially much simpler than a bacterium. They were called protobions. They were basically formed by a ball of fat wrapped in RNA that were formed in a hidden period. From there, new periods were formed and life on Earth became much more complex than one could ever imagine. Later, we went through the Archean periods, the Proterozoic periods, the Cryogenian period, and the Ediacaran period. And after that, the multicellular beings evolved and acquired different characteristics, differentiating so much so that today they are considered different species. And the rest is story. The story of geological evolution and life on Earth. Evolution and the human being itself. It is our story. But that's a subject for another video.
Hello, my name is Matheus, and I will talk about the review of the content of the video. Well, now you know how the cosmos come to be. We will then explain the influence of each of the disciplines in the context of the Big Bang Theory. We used physics in the fundamental laws of the universe that explain the density and the age of the universe. We use chemistry to explain the formation of stars, planets, atmospheres, and the particles that make up the cosmos. We use biology to explain the formation of life on the Earth and its evolution.
So, this was a brief story of the most popular theory in the universe. If you ended up enjoying it, then consider subscribing. It'll help us a lot. And leave a like, so that we know that you're liking this content. And thank you so much for watching this video.